Good day guys, welcome back to our channel New Age Maritime Academy. Chief Engineer Krishnan here, and this session I intend to discuss with you regarding ballast water treatment system, and mostly I have been with electrolysis type. I intend to give you a rough idea of the system, how it is working, and so that if somebody asks you something in your orals or you will have some idea. I'm not going to go in depth. I'm just going to give you an overall outline of the system. That's all. So regarding ballast water treatment system, as you know very well, to start from the beginning, by 8th September 2024, next year September 2024, 8th September, all vessels needs to follow D2 standards, needs to have a treatment system installed. In your ballast management certificate in your ship, if you see, you will have D1 and D2 standards. Okay, D1 standard, as you know very well, it's a conventional system where you have to carry out ballast exchange. Okay, so this is the minimum requirement. This is the D2 standards which has been put into force from 8th September 2017 for ships built on or after 8th September 2017. This has D2 is made compulsory. Okay, as per the ballast water convention, this is the new ship. All ships which are constructed on or later than 8th September 2017, this comes under new ships. Existing ships means, as per this convention, the ships that are built before this. Okay, so what they need to do is, during their next renewal of IOPP, they need to install BWTS. They need to install treatment system to comply with D2 standards. Okay, so anyway, this 8th September 2024 is the target date that all vessels must follow D2 standards. In the sense, they need to have a treatment system installed on board. Okay, if it is an existing ship, that means they should have retrofitted. As I told you before, if it is a new ship, the ships which are as per this convention, ballast water convention, ships that are built on or after 8th September 2017 will have the BWTS system fitted in when the vessel is built itself. So when it is delivered, it comes along with the vessel. For other ships, it will be a retrofit. Okay, so the purpose of the treating the ballast water, you may be having a fair idea that it is spoiling the marine ecosystem. Okay, so I am not going to explain that, but one thing which you need to remember is, by using the treated water, in the sense by D2 standards, you are getting a treated water, no? So you are basically treating the ballast water which is going inside the ballast tank. Okay, so by treating the ballast water, you are protecting the ballast tank's coating. See, if you see, you know the corrosion is a chemical process. So you have, if you give treated water inside the ballast tank, it won't aggravate the corrosion process. Still, lot of studies are going on, like how a treated water, because some of the treatment systems, they have found it is aggravating the corrosion process also. So there is some deterioration also. There is some findings, but still it's under actually, to eliminate this kind of these things, what is actually happening is, most of the systems, your ballast tank is protected, because while they install the treatment system, basically the tank coating you are preserving. That is what actually you are doing. You are extending the life of the tank coating, ballast tank coating, by reducing the corrosion process. That is the main aim. From the from the technical point of view, environmental point of view, how it is, if you, in the sense, if you do ballast exchange, what are all problems will happen without treating water, without untreated water. If you deballast, how it is affecting the ecosystem, you already know it. So, but from the technical point of view, this is the advantage. You are preserving the ballast coating of the ballast tank. So what happens is, usually depending on your paint maker, suppose you would have heard Hempel. I'm just giving an example. Hempel or International, these are all some of the paint makers. So it's what owner does is, when he fixes the treatment system, it's better that the paint maker knows this is what is happening actually. It is, I am not suggesting, it is just what is happening in the present day scenario I am telling. The paint maker knows the quality of the treated water inside the ballast tank. Okay, that they will arrange, that the BWTS maker will arrange. This is my sample, this is the lab report of that sample, and this he will give to the paint maker like Hempel or International. Then paint makers suggest to the vessel owner what kind of coatings is advisable for this kind of water which is coming into the treated water, basically, which is suitable. This much is the TFT, this should be the primer, total TFT should be this much paint thickness. So basically this is how they are balancing actually. So this is just for your information. I don't know how many ship owners do that or how many companies do that. This, while going through the journals, I just happened to get this here and there. So just a marine news, same like other news, but definitely not galley news. So anyways, this is one of the advantage of BWTS system when it comes to technical point of view, and how the owner is suggesting, how the owner is deciding what kind of treatment system I can use. There are various types of treatment systems which we may be aware of: electrolysis type, UV type, deoctification, chemical injection, ozone, heating. So like this, lot of types are there. So how the owner usually, how they decide is depending on the space, power consumption, amount of ballast. The treatment system should match with the vessel's ballasting and deballasting capacities, basically the ballast pump capacity. We cannot tell that since I am running the treatment system, my cargo I cannot load so fast. That nobody will accept. So your treatment system capacity should be able to cope up for the vessel's commercial operation. That's how they will be designed. Okay, so these things you may be knowing, of course. Just a recap. So coming to this session, suppose for the quality of the treated water, okay, be it any type of system. I told D1, D2, no. The D2 standard, how the IMO has told that the treated if you run the water through the ballast treatment system, and by the time it enters into the tank, there are some standards, and when it goes outside there are some standards. Basically, if you see, sometimes PSC also checks takes the sample. It happened in our vessel also once, not this vessel, before. The PSC came and took the sample of the 4-peak tank. Okay. See, what they are basically interested is in whether, of course, all the systems are approved systems. Okay. They cannot simply put anything without any approval. All the BWTS system, same like your incinerator and other MARPOL equipments, they are all approved, USCG approved, mostly. So how they are giving approval is the sample of the treated water. There is some, you can remember this later on also when before you go for orals, for 1 meter cube of water should be like, less than 10 viable organisms. Viable organisms means basically by treatment system you are killing the microorganisms and making them invasive. In the sense, they cannot multiply. That is what you are trying to do. Okay. For example, by means of by germicides or by applying UV rays, you are by heating or something, you are basically killing the microorganisms which are present inside the seawater. Okay. So this less than 10 viable organisms, bigger or equal to 50 microns. So there's these things little bit you go through because one more thing is also that I am telling you roughly. Okay, see, actually what had happened was we were running around in BWTS, so of course, so I have the habit of sharing with you in the things which little bit I am running around, so that memories are fresh. So which I felt that it will be helpful for you, for me, and so that I can share it in a very easy way. Honestly speaking, I am not too much reading and telling you all these things, as don't feel I am going to too much theory or something. Okay, so this is a D2 requirement standard. Okay, before you go for your oral, just have a look what should be the requirement. This is the one, I think, less than 10 viable or equivalent to 50 microns. Okay, so now what I am going to discuss with you is, I have been working with the electrolysis system. Okay, just a basic idea I will tell you how it is, what is going on. See, this is the ballast pump. This is the ballast pump. Okay, you are first passing it to a filter. This is actually a 50 micron filter. Okay, where you will have some kind of back flushing arrangement with that, and then from the filter one line goes to, this will be another pump coming inside. So this is the filter with the backwash motor. Okay, then it goes to a pump which supplies to the electrolysis unit. Okay, see, another, this is the main line. This is going towards the ballast tank. Okay, you'll have some flow meter or whatever here. Okay. This is a ballast tank. This is a flow meter. You'll have something called electrolysis unit, and from there you will go to the TRO. TRO means total residual oxidant. Okay, I'll come to that when I am showing the outline of it. Then goes here. Just a rough outline I am telling. This is what is happening during ballasting. Okay. Filter should be of 50 microns because, as I told you, as per the D2 standards, it should not be bigger than that, the viable organisms and all. So what is happening here? First you pass through the 50 micron filter. The entire water has to pass through. Okay. And then a part of the system, this only, it is not the full system going here. If you see, this is the main line. This is the main line. Okay. It's only 0.5% you can assume. 0.5% only this system is occupying. This system. This is the main line. Then going to the ballast tank. Okay. Then here what you are doing is, you are doing electrolysis of seawater is you have to do to produce. This outline I hope you are okay with this. From the electrolysis what is happening and TRO what is happening, I will just brief you, just a quick brief. And then it goes to this is actually the injection line basically. It's basically what you are doing is, by electrolyzing the seawater, you are producing a sodium hypochlorite chemical, NaOCl. Okay, this is by electrolyzing you produce this chemical, and then you are injecting the chemical in the main line. This is what you are doing. And for producing this chemical, you are using the same seawater. Only 0.5% of the system water goes there. There is no external means. You are not putting any external chemical during ballasting. Okay. While deballasting, we use sodium thiosulfate, which acts as a neutralizing chemical. That I will explain you while I come to deballasting process. Okay. So what is happening by electrolyzing this electrolysis? By doing electrolysis, you are producing this sodium hypochlorite, and then injecting into the main line. Okay, and then sending it to the ballast tank. This is what is happening. Okay. So now what is happening? This is just a rough sketch I am telling. So now you are telling, by injecting a sodium hypochlorite, this is basically a germicide. I am killing the viable organisms or microorganisms and making that invasive, and basically killing it, and then sending inside the treatment ballast tank. Okay, this is what is happening during ballasting process. So now if you see, I told you about electrolysis. Okay, that pump which I showed you, this is the filter line. Okay, from the filter line, this is the main line going to ballast tank. This is from the pump, ballast pump. Okay, this is the line where I draw the pump for the electrolysis unit. See, what is happening in the electrolysis unit is, you will have a rectifier which gives assume like this. Okay, See, this is the blower which removes the, okay, one by one I will tell. You are allowing the seawater to get electrolyzed. Electrolyzed means what? You are passing DC current, okay, where imagine like this is seawater, no? This is the seawater, right? This is the seawater. This is what is happening. This is having H2 gas. Here, by means of electrolysis, you are producing sodium hypochlorite and hydrogen gas. Okay. What is happening is you are splitting the seawater using the current, okay, which is supplied by the, you are supplying AC current here. Okay. You are supplying AC current to the rectifier. This supplies DC, rectifies to DC, AC to DC, and this unit you can assume it as plates. For electrolysis, what you need? Electrolyte, current and conductor. That's all you need, no? These plates act as a conductor. That's all. So that's why this reaction is happening. If you pass current through the conductor, if you pass through DC current, anode, cathode, so what is happening is, this is the thing which is happening. Seawater, this includes energy. This is what plus energy. Energy means electrolysis process, current process, applying the current. By externally you are applying the current, DC current, and then splitting it to sodium hypochlorite and hydrogen gas. And during this, hydrogen gas is produced. This sodium thiosulfate solution, okay, and this goes actually here. This is a hydrochlone converter, hydrochlone, where it will be like this spiral. This separates the liquid and gas, okay. At the, you don't, all the gases you have to emit. You will have a chlorine sensor and hydrogen sensor, and then this will be exhaust by the, this will be run, it will be exhausted from the engine room, and this pipe will be going to the, if you see in the upper deck, you will it will be marked in yellow, okay. And that's why these are all interlocks and all are there. If you don't run this blower, you cannot start the system, okay. I am not going to in depth, I am just telling you an outline. So from here in the hydrochlone, this thing separator, this basically acts as a separator. Hydrogen gas is emitted here and then thrown outside, and then here the liquid will come, basically sodium hypochlorite. This will come to the injection line. This is what is happening in the electrolysis process. See, when I am doing in the online session, I will discuss with you, because here, since this is a very overall session, I intend to put a topic of ballast water treatment system in detail. That time I can explain you how much current you need, how much the current varies, how, what are all issues you can face, all those things I can discuss with you, okay. Now during the deballasting process, what is happening is, see, now you have put, it is passing through the TRO also, okay. So during ballasting, okay, first then I will show you the TRO system first. Ballasting, as I told you in the overall, in the outline of the system, this is the main line to ballast tank. You have a TRO. This is the chemical injection dosing line you can call, or chemical dosing line or whatever, which is coming from the outlet of the hydrochrome separator. Okay, this passes through the TRO and then only it will come. Okay, see this, you will have a sample valve. You understood, no? Whatever the chemical which you are producing from electrolysis unit, this is the line coming from electrolysis unit. Okay, which we are telling, which is being need to be monitored by the TRO. Okay, I will tell you now what is happening here. Then then it joins the main line. Okay, basically you are mixing with the germicide. The main line is being treated with germicide before allowing into the ballast tanks. So in the TRO, what is happening? Basically it is see what is happening here. TRO, it gives the concentration of chlorine which you are injecting in the main line. Basically this is the germicide, no? So this is like you are measuring how much germicide I am injecting inside the main line of the main ballast line. Okay, for killing the microorganisms. This only kills, basically this is a concentrate. This is actually that's why they call this active substance. This is basically a concentrate. This concentrate, in the sense that injection line is having a concentrate actually, because chlorine, no. So this gives, during ballasting it should be 2.5 to 3 ppm maximum, between 2.5 to 3. Accordingly the system will react. Adjustment of with respect to the TRO value only, all the parameters of the system gets adjusted. That's why I am telling how the adjustment is being done. That I can explain you during the online session, where I can have some more slides, and I have experience in Samsung polymer basically. So with that I can show you the exact video of what is happening, because now as I told you in other videos, I am on board, so not possible right now. So for ballasting, this is during during ballasting. Okay, during deballasting, what you are doing, the same TRO measures the this is the overboard line. Okay, when you deballast the tank, this is the overboard line. What will happen is, you are measuring the, here is a sample, you are measuring the, you have the TRO here, which is measuring during sample should be not less than only 0.1 ppm, because what you are doing is, basically during deballasting, as I draw the ballast system before, basically during deballasting, what is happening? Okay, assume this is the ballast tank. I hope you understood, you had a rough idea of what is happening during ballasting system process. Okay, I hope you got an idea. So this is a ballast tank, the ballast pump, and this is a treated water. Suppose you assume this is a treated water. What is happening is, you have about 2.5 to 3 ppm here inside that, in the sense concentrate, which has been mixed with the main line. So this water has to be neutralized. So what is happening is, here you have a separate chemical. Deballasting is very simple. Ballasting only is actually a bit complicated when it comes to electrolysis system, because your electrolysis has to function properly. Okay, the TRO value should not come below 2.5 also, and should not go more than 3 ppm also. The system will trip. There is a timer set, it will trip. So, but ballasting, you are having external chemical, sodium thiosulfate. Okay, this you are using sodium thiosulfate. This is a neutralizing tank. This is a neutralizing tank, and from here there are small dosing pumps which you are using, and then putting it in the main line, okay, so that it will neutralize this water. This is what is happening during deballasting process. And during deballasting process, so it's very simple, you are just injecting a neutralizing chemical, that's all, to neutralize because you have injected a germicide, you have to at the same time, before sending it overboard, basically you have little bit, you have to neutralize it, because you put that germicide. Basically, you are in the sense, it should not go more than 0.1 ppm during the deballasting operation. So if it is going more than 0.1, it will trip. So this is how the things are functioning. Okay, when it comes to electrolysis system, and this is what is happening. During my online session, how far it will be useful for your orals, like for class 4 student, they may ask you what kind of treatment system you had, show the drawing of, show the outline of the treatment system. But for class 2, they may ask you what are all problems you faced, why the TRO value is not getting stabilized while ballasting, and why the TRO value is not why the TRO value is too much going up while deballasting, why the system is tripping, basically. All these things and all, they may ask for. I am not sure, but if you see nowadays, most of the ships are having now. So the expectation will be there. So that's why whatever discussion I am doing, it's not only for knowledge sharing. I also intend to help you, in the sense, this may be helpful for your orals. Okay, especially when you have a external as a sailing chief engineer, because definitely he will face all these issues on board. So the main purpose is whether you have taken some initiative on board to learn the system and how to control it if there is any issue. And at the same time, for people who are coming at class 1 examination for chief engineer or master level also, now you have a situation just 5 days before arrival port, your BWTS system is not functioning properly. So how you are going to handle the situation in terms of reporting, in terms of answering to the PSC, because this is what we are doing multiple times. See, all these things and all, I'll be very happy when the interactive class is there. So that's why I'm telling, during my interactive session I can explain about all these things. Although for class 1 we have not planned for our in our system, but the session for specialized courses, we are still in the planning stage actually. Myself and 2 of my friends, electronic engine and BWTS and all, these are all specialized courses, so anybody can attend. It's not that only these people should attend or this. It's not like, we are not segregating the candidates from our side. We are open to everybody. We invite everybody basically, and definitely we would like to also hear if you have had any interesting issues. Actually, basically this is a forum for, for common interest. So anyway, why I am telling about PSC and all, suppose if you have happen to have the system shut down, people who are attending for class 1 may be useful to you. You cannot, they will see step by step what are all things that have happened. Okay, if it has happened 5 days before arrival, if the system has malfunctioned, okay, you have reported, but where is the record of the system running in the last port? Everything is actually recorded, and it's actually a tamper-proof record. One thing I want to tell you guys, please don't think only OWS or OCM or only the Annex 1 missionaries are tamper-proof. The amount of penalty, I am telling with the present day scenario, I am telling the amount of penalty which they are imposing for Annex 1 is with the same iron hand they are dealing for Marpol Annex 6 also and for BWTS system also. Okay, so things are actually a bit tight, but only thing is our response has to be proper, and as a master and chief engineer, with the present day scenario of with these new systems, lot of proactive response is required in coordination with the company and in coordination with the maker, because most of the problems which I will be discussing you in the online classes, some of the problems we cannot eliminate from the vessel side. The technician takes the remote control of the system online, and he will upgrade the software and all. Okay, so software upgradation is there, and changing the logic is there. Logic program, I am meaning these are all basically, the BWTS system is fully automatic. I hope you know. You are aware of that. So basically these are all software. The software should not get corrupted, or PCB also may go. All these things are associated problems in the system, and if these things and all are happening, it will be difficult for the ship staff to rectify. It's actually out of the scope of ship staff. So technician will sometimes take after we report this, what is the issue happening, they will take the system online, and then they will rectify it. So this is one thing. And regarding the functioning of TRO, just a rough outline. What is happening is, this is the injection line. From here there is a sample valve, injection line, or wherever, this is the line. Here you will have a box, something. I am just giving you a rough outline. Okay, this is a TRO unit. Okay, it goes inside the sample. There will be a small pump here, Wilton pump, basically a small Wilton pump will be there, giving the sample inside. Okay, what is happening is, just assume this from the Wilton pump. Okay, this you can tell a sample pump also. Okay, I will just call it a sample pump. Used to there is one thing called cuvette. Okay, how it is functioning, I am just giving you a rough outline. You will have this is a sample going inside. Okay, this called, you can assume it as a tube, a transparent tube, which they call as cuvette. And inside the transparent tube you are running the sample inside, and another side you are having another pump. This you can call reagent pump. Okay, which is putting the reagent also inside along with the sample water, and here there will be a color change happening. Okay, this color change is being sensed by the optic sensor inside the TRO. The functioning of the TRO unit is almost the same for any system. Okay, mostly this is the working principle. After seeing the chemical reaction, there will be a color change, and with the color change there will be an optic sensor installed here at the back of the unit, at the back of the cuvette, which will be sensing the sample at the regular intervals, and then displaying. Once it senses, it displays the you got an idea, no? The color change is what is important. The color change, there are various type of color changes happening, which I will be sharing the video during my online session. Okay, the color change, the sequence should be normal. So then the optic sensor will be inside the TRO. This gives the display, sense it, and then gives how much is the value of TRO. Suppose if it is 2 ppm during ballasting, it will sense and then it will display the amount of what is the total residual oxidant level in ppm. This is what is happening, and the rest in detail, if you can see in the session which I am planning to conduct online. In the meantime, if you want to contact me regarding what is our plans, because we are actually right now we are in the planning period. Side by side we are giving YouTube videos. That is what we are actually doing. Our intention is we will be starting the online classes for class 4, class 2, and apart from that, specialized topics such as BWTS, scrubber, electronic engine, I will try to cover. That specialized topics, mostly it will be a combined class, because see, BWTS and all, everybody is being asked. So for UK students, for anybody, for Singapore students, topic is the same.